Credit scoring demands both predictive accuracy and clear justifications for each decision. Concept bottleneck models, or CBMs, address this challenge by inserting a layer of human-defined concepts, such as debt-to-income ratio or payment history, between borrower data and the final risk score. By structuring the model this way, every prediction becomes a transparent glass box, enabling inspection, correction, and trust without sacrificing performance. This presentation describes concept bottleneck models and their role in building trustworthy credit scoring systems. 6 key topics are covered: definition, architecture and training, trust and accountability, interpretability challenges, performance, and finally strengths and weaknesses. CBMs map raw borrower data to human-defined credit concepts for transparent risk analysis. Tabular concept bottleneck models transform raw borrower data into a layer of domain-relevant credit concepts before making any risk prediction. On the left, we feed features such as salary, outstanding balances, and employment status into a concept predictor, which outputs 5 interpretable credit metrics: debt-to-income ratio, credit utilization rate, loan-to-income ratio, credit score category, and loan purpose. A downstream label predictor then uses those concept values to produce the applicant's final risk score. By forcing every decision through named credit concepts, CBMs give loan officers a transparent glass box view of why each decision was made. The next slide details the 2-stage pipeline architecture that separates concept prediction from the final risk score prediction and credit scoring. A 2-stage CBM pipeline separates concept prediction from task prediction, providing both transparency and intervention. This split view figure shows the architecture of how concept bottleneck models work in general, which is on the left, and for credit scoring on the right. The left panel is a generic CBM where raw input X, such as an image or a feature vector, feeds into a concept predictor, which outputs a vector of predicted concepts, C hat. A downstream label predictor then consumes C hat to produce the final task output, Y hat. The right panel, the credit scoring CBM, the borrower features, income balances, employment, and history are mapped by the concept predictor into 5 interpretable credit metrics, yielding the C hat. The label predictor then uses C hat to compute the loan's risk score. For example, the probability of default. During training, the model minimizes the concept loss to align with C hat, with ground truth annotations and the task loss on Y hat to improve prediction accuracy. At test time, because every decision flows explicitly through the concept layers, loan officers can inspect or correct any individual concept value before the label predictor runs, providing full transparency and real-time correction capability without retraining. Building on the 2-stage pipeline, the next slide illustrates how explicit credit concepts empower real-time inspection and correction of model outputs. Explicit credit concepts enable loan officers to inspect and correct model decisions in real time. By surfacing each prediction as a set of interpretable credit concepts, CBMs put loan officers in the driver's seat. This dashboard mockup plots concept contributions, so a loan officer instantly sees how factors like debt-to-income ratio, which is plus 0.25, or credit score category, minus 0.08, push the risk score up or down. If the DTI is incorrectly estimated at 78%, the officer can simply adjust the correct 55% and the risk score updates on the spot. For example, from 0.62 down to 0.45 with no retraining required. This real-time correction capability fosters genuine trust by keeping humans firmly in control of every credit decision. Actionable transparency fosters trust, but concept fidelity issues and false interpretability introduce critical challenges. Naive concept supervision can create false interpretability, undermining trust and accountability. Here's a direct comparison of false interpretability. On the left, saliency has has wing pattern, which floods the entire bird, legs, background, and all, rather than the wing, which obscures the prediction. Right, credit scoring mockup, a joint tabular CBM for late payment mirrors that failure, diffusing attention across all 5 credit features instead of just focusing on the true payment history. Such misaligned concepts mislead users, masking spurious correlations and erode both trust with unclear evidence and accountability, hidden errors. Rigorous fidelity checks like target saliency audits or counterfactual edits are essential before deploying CBMs in high-stake lending environments. After highlighting interpretability challenges, the next slide demonstrates that CBMs deliver predictive performance on par with leading black box models. CBMs achieve competitive credit scoring performance while providing glass box transparent insights. On the FICO credit scoring benchmark, Concept-Bottleneck models deliver an ROC-AUC of 0.7208, matching or slightly outperforming established gradient-boosted baselines, such as XGBoost at 0.7233 and Light GBM at 0.7263. This result shows that embedding interpretability via human-defined credit concepts does not come at the cost of accuracy. CBMs therefore offer the best of both worlds for financial institutions. State-of-the-art performance together with glass box explanations that loan officers and regulators can inspect and trust. The following slide assesses CBM's advantages and limitations through a simple SWOT analysis. While CBMs enhance credit scoring transparency, they also face challenges in concept fidelity and generalization. CBMs bring clear benefits to credit scoring by making every decision traceable through human-defined concepts, empowering loan officers to make real-time corrections and matching the accuracy of top black box models. Yet these models can suffer from concept fidelity lapses, where learned proxies drift from their intended meaning, and may struggle to generalize when applied to new borrower portfolios. There's a strong potential to strengthen CBMs through targeted fidelity audits and counterfactual interventions to expand their use across other financial services, such as mortgages and small business lending, and to leverage glass box explanations for regulatory compliance. At the same time, vigilance is necessary to prevent the misinterpretation of concept outputs and avoid overfitting to narrow data sets and strike a balance between maintaining interpretability and managing complexity. In conclusion, by embedding human-defined credit concepts at the heart of model predictions, CBMs offer a powerful path to transparent, trustworthy lending decisions. Realizing their full promise will require industry collaboration on standardized concept definitions, combined efforts to develop robust fidelity checking tools, and ongoing research into scalable domain adaptation. As financial institutions move towards explainable AI, CBMs stand ready to bridge the gap between regulatory demands, operational needs, and advanced machine learning. Thank you.